All right, IBAISL2 kids, we're going to go over bivariate data today. So bivariate, it's got that word bi in it, like a bicycle has two wheels. Bivariate data has two variables. The same way univariate data, just like a unicycle has one wheel, univariate data only has one variable in it. Whenever we're talking about bivariate data, we can talk about the correlation between the two. Today we're going to talk about just like some basics of correlation, and then in the next learning target we're actually going to get deeper into correlation. It's all about the connection between two variables. One of my favorite examples of correlation is ice cream consumption and shark attacks. It is 100% true that in coastal towns, that the more ice cream is consumed in the town, the more shark attacks will happen. Now, I always get students to try to talk about why this might be happening, and there's lots of wild theories, like if you eat more ice cream, then you're tastier to sharks and things like that. But the actual reason is that the two have nothing to do with each other. So it's true that they do have a strong correlation, which means that as ice cream consumption goes up, shark attacks also go up. This is because of a confounding factor between the two. So like shark attacks don't cause ice cream consumption and vice versa. Like eating ice cream doesn't make it so you're going to get eaten by a shark. It's because temperature is a confounding factor here. As the temperature increases, more people eat ice cream, and also more people go into the water, and then therefore, shark attacks happen. Shark attacks are very rare, by the way, but it is true that the more of them that happen in a certain place, the more ice cream is eaten. Some classic correlation without causation. Oh yeah, so there's no causation here. They're correlated for sure, so correlated, but not causated. Classic correlation without causation, the number of people who drowned by falling into a pool, and films Nicolas Cage appeared in. Notice like in 2002, they both had a little bump right here, and then in 2007, 120 drownings and 4 Nick Cage films. So very high correlation, but low causation. I don't think one's causing the other. Some other classic examples: per capita cheese consumption and number of people who died by becoming entangled in their bed sheets. The age of Miss America and murders by steam, hot vapors, and hot objects. This one's wild. Look at the trends. They follow each other so much. Does that mean the oldest Miss America is 25? Interesting. Now let's talk about some words we can use for types of correlation. So you're going to be looking at some scatter plots. If you see a scatter plot that's kind of going uphill, this is called positive correlation. If it's trending downhill, this is negative correlation. It's the same thing as slope. If the line's going uphill, that's positive slope. If it's going downhill, that's negative slope. Sometimes you'll get kind of a snowstorm situation like this, and this we would say there's no correlation. Now, this is just visually looking at the scatter plots. Also, if the dots make a very close to a line, this is called strong correlation. If it's like, a little bit loose sort of thing, this is called medium. Moderate is what some moderate correlation. And if it's like, it's still going uphill, but it's not very close to a line sort of thing, this would be called weak sauce. So, our first example, the table gives heights and weights of 10 camels. Wow, classic math problem. I posted a video before this about how to make a scatter plot on your TI. If you draw a scatter plot, it looks something like this. So comment on the relationship. I would say this is, they look pretty tight. So I'm going to say this appears to be a strong, positive relationship. Let's use the word correlation since that's what we're talking about. Book says relationship. I'm going to say strong positive correlation. So that means like the bigger the taller a camel is, the more it's going to weigh, and vice versa. The more it weighs, the taller it's going to be. Makes sense. Next example, members of family in each of 9 families and the number of pets the family has. So if we draw a scatter plot for this guy, it looks something like this. When I look at this, I see that it's trending uphill. It is kind of going this direction, but I don't think it's clustered very well. So I'm going to say this is moderate, spell moderate right, positive correlation. State whether with a reason whether you think one variable causes the other. This is where you kind of got to put on your philosopher hat a little bit and think about if there's, one is influencing the other. I'm going to say that the number of members in a family doesn't influence the number of pets. Oops. They're essentially asking you about causation, like ice cream shark attacks. There's no causation. Last problem, this table shows the number of schools and the number of restaurants in a town over a 40-year period. So this is confusing when you draw your scatter plot because some people put this as L1, but you actually don't need that at all. This is going to be your L1, and this is going to be your L2, or this is going to be your X, and this is going to be your Y. I believe that's the way they did it. Yeah, schools is on the bottom, and restaurants is on the side. Okay, the scatter plot looks something like this. So, describe the correlation between the two variables. I think this is a strong positive. Yeah, do they agree? Oh, yeah, strong positive correlation. State whether you think that one variable causes the other. I don't think that directly one causes the other, but I do think, I don't think they directly cause each other. So I'm going to say, so this was part A, this was B. Does one cause the other? Not really. It's not like if you build a restaurant, then a school gets built. But I do think that the reason why, it says state a possible reason why the number of schools and the number of restaurants increased over the 4-year period, is that population is the confounding factor here. As population increases, so will the number of schools and number of restaurants will increase when you have more people. So more people equals more schools, and more people equals more restaurants. Oh boy. All right, guys. Good luck with your homework. Hit me up if you have any questions.